Okay, this is question number 5 on the booklet. We've got a proton coming into this magnetic field here, shown by these little crosses going into the paper, and the question says, what is the time taken for a complete orbit? What we should know is that when a charged beam of particles comes into a magnetic field at right angles to it, it will be bent into a curve and will do a complete circle, either that way or that way, and to work out which way it goes we need Fleming's left-hand rule. We're not going to bother with that right now because we're not interested in its direction, we're just interested in the time period. So let's write down what we know. This deflection must be caused by a force, so we've got F equals BQV over here, that's the force on the charged particle. We know because it's moving in a circle that force is also equal to the centripetal force, which is mv squared divided r. And often in these questions what you need to do is put these two equal and make some calculations. What makes this one particularly difficult though is that it asks us for the time period and there's no t value in these two equations. So we're going to need to use a third equation which has time in it, and the one we need is time equals 2 pi r divided v. This comes from speed equals distance divided by time. Rearrange time is distance over speed. So we're going to have to use this equation here, and we 2 pi we know, but we don't know r, we don't know v. So we need to somehow use the top two equations to find those. So what do? Well, if we put those two first equations together, BQV equals mv squared over r, v and v squared cancel, and we can rearrange, make v the formula, v the subject rather, and v equals bqr divided m. That gives us a value of v. We can now substitute that back into this one over here, t equals 2 pi r over v, and we should be able to work out the value of t. So if we do that, t equals 2 pi r over v. V is quite a big equation, a big fraction, so it's easy to write 2 pi r times 1 over v, 1 over the reciprocal, 1 over v is over here, m over bqv. So if we put 2 pi r times by m over bqv, put all of that into the equation, and we end up with 2 pi m over bq, or as the answer says, 2 pi m over be. They use e for charge instead of q, that's fine, which is answer D.